Example 3 takes us back to example 1, f plus g of 5, f times g of negative 1, and f over g of 4. This time it's not asking us for domain, it's asking us to evaluate, right, to find it. Notice instead of f plus g of x, it's f plus g of 5. Okay, the easiest way to do this, f of 5 plus g of 5. Separate it into two separate problems, and then add because that's what it's telling us to do. So if I'm going to evaluate f of 5, I go to f of x. I would place x with the number 5 and work it out, right? So 5 squared is 25 minus 9. That's f of 5. To that, we're adding g of 5. To do g of 5, I go to function g, replace x with 5. 2 times 5 is 10 plus 6. So 25 minus 9 is what f of 5 looks like. 10 plus 6 is what g of 5 looks like. I did a little simplification in my head. 5 squared, 2 times 5. Feel free to do that kind of stuff. If I simplify both of them then, 25 minus 9 equals 16. 10 plus 6 also equals 16. So f plus g of 5 is going to equal 32. It's like functional value used to be. F of number, you evaluate by substituting the number in for x, and the answer you get is the answer. Alright? So 32 is the answer. The fact they both happen to be 16, that's coincidental. They don't have to be the same number. In this case they were. Next problem, we have f times g of negative 1. So that means f of negative 1 times g of negative 1. Same deal. We're multiplying f of negative 1 and g of negative 1 together because that's what it's telling us to do. F times g. So f of negative 1. What's negative 1 squared?
1.
1 and 1 minus 9. And then for g of negative 1, 2 times negative 1 is negative 2 plus 6. Be cautious when you replace x with a negative number that whatever's happening to x, both sign and number are being raised to that power. So that gets me negative 8 multiplied by a positive 4, which makes negative 32. So far we got 32 and negative 32. That's also coincidental. It doesn't always happen to be the same number with opposite signs. Get what you get. You know, this came out to 6 and that came out to 3. The answer would be 18. So get your answers, multiply them together. That's how you do it. Okay, to do part 3, part C here, f over g of 4. Okay, that means I want to do f of 4 and divide that by g of 4. Okay, what would the only issue be here?
If you get 0 on the bottom.
If we had 0 on the bottom, in which case 3 possibilities exist. 0 on top over 0 on the bottom is indeterminate. Number that's not 0 over 0 is undefined. 0 over a number that isn't 0 is 0. So those are your 3 possibilities. So 0 over 0 is indeterminate. Number that isn't 0 divided by 0 is undefined. And 0 divided by a number that isn't 0 equals 0. So those are your 3 possibilities. If 0 happens to show up, that's how you handle that. I'd like these 3 answers. I don't want you to leave 0 over 0, 75 over 0, or 0 over 33 as a final answer. So just either equals 0, undefined, indeterminate. Those are what I'm looking for. That happens occasionally. Okay, it's not going to happen this time, but it could happen in your homework. So f of 4 means I'm going to take 4 squared, which is 16, and subtract 9. G of 4 means I'm going to multiply 4 times 2, which is 8, and add 6. I'll work that out. 16 minus 9 on top is 7. 8 plus 6 is 14. And that reduces to a half. Okay? So, if you're evaluating, that's how you evaluate. If you're finding domain, you're going to get an f plus g of x, f minus g of x, and then find the domain. If you're doing a difference quotient, you apply the difference quotient and just simplify to the extent you can. H's should all cancel at the end. If you don't get h's canceling, chances are you didn't change the sign on f of x.